Hey everybody, this is Miss Wilson. These notes are podcast style. Couldn't come on camera today, but I still wanted you to be able to do this one self-paced. So this is classifying matter into elements, compounds, and mixtures. You need to have a note page. It is a hole punched page that says elements, compounds, and mixture notes at the top. It is only one-sided. If you do not have that paper, pause and go get it. So we're going to define some things. First of all, we're defining pure substances. A sample of matter that has definite chemical and physical properties. So again, if you have the right paper, you're writing in the word chemical and the word physical, right? So follow along, make sure you have that paper. So we're talking about a pure substance for our purposes. Like here they have this picture that shows oxygen. That is a pure substance because it's one element. For our purposes, another way to put this is to say a pure substance is one single element, right? But also, it could be one single compound as long as there's nothing else. So I can have, this kind of looks like H2O. I can have pure H2O as long as there's nothing else in it, as long as there's no other molecules happening, okay? So a pure substance that cannot be separated into a simpler substance by physical or chemical means is what we call an element. So I'm scrolling back up for a second. Oxygen is a pure substance, but like I said, H2O can also be a pure substance. Okay, it has multiple elements, but as long as nothing else is in the mix, it can still be a pure substance as long as these are bonded together. In the case that there's nothing bonded together to take apart, then that's when it's just an element as well. Okay, so an element is a pure substance that you can't break it down any further. There's no way to take this Be beryllium apart. I'm not taking that apart. It's just a beryllium and it can't really change from that. Okay, so a compound is a pure substance. Like I said, it could be H2O, composed of two or more different elements joined by chemical bonds. Okay? Chemical bonds are like what's holding these H's and this O together. Okay? It's always the same. Water is always H2O. It is never H2O2. That's a different thing. It's never just OH. That's a different thing called hydroxide, right? So H2O, two H's to one O, that's water. Any other ratio, meaning how many H's to how many O's, is a different thing. Okay, it has a chemical formula such as H2O or NaCl, which is sodium chloride, which is table salt that you put on your food, or CO2, which is carbon dioxide. It can only be separated chemically, not physically, by chemical means. I cannot take H2O apart into hydrogen gas and oxygen gas without doing a chemical reaction. I cannot take sodium chloride apart without doing a chemical reaction. I cannot take carbon dioxide apart without doing a chemical reaction. I can't physically break these, okay? That makes it a compound. A mixture is two or more pure substances that are not chemically combined. They're not bonded together. We can't write them down as these type of little things here. It's more complicated than that. They're in there physically, not really chemically. There's no chemical change, okay? Each item retains its properties in the mixture. It looks like the words got covered up a little bit, so let me look at my paper and find where we are here and make sure you have what you need. Each item retains its property. So retains, you can see that. They can be, so this is covered up. They can be separated is the word that's supposed to be there. Separated. That's S-E-P-A-R-A-T-E-D. Like this word separate here, right here that I'm clicking, but add a D to the end. So I can take tap water and use a filter, which is physical, in order to get the stuff out of it and distill it. I don't have to do a chemical reaction. If I want to separate the hydrogen from the oxygen in water, I have to do a chemical reaction. Okay, that's the difference. A mixture is just mixed together. Okay, like this. They show a block. You can crush it. That's physical. turn it into dust, that's still physical. Melt it, it's still physical as long as the melting doesn't change it chemically. And then it is into separate things, okay? Because they might solidify at different temperatures or whatever. I can take this block that's mixed up stuff and physically separate the parts of it, okay? This is a table. You don't have a place for this on yours. I would recommend you, this is a bit much to write, but maybe we can shorten this. So maybe on the back of your paper, so flip over, and then let's make this chart a bit shorter. You can do composition, have mixture and compound. And then, but you don't have to write this long stuff. You can just remind yourself, composition for mixture, it's variable. For compound, it's definite. Joined or not joined. Not chemically joined. And compound is chemically joined. You see what I mean? So break that down to really small phrases. And this would be a good thing to have on the back of your paper. Yes, you need to do it. Do not ask me, Miss Wilson, do I have to? You have to, yes. Properties. Keep its own properties, okay? And then compound, different from the elements it contains. That one's a little longer, even when you shorten it. Separation, easily separated. Separation for compound, chemical reactions only. Examples of a mixture is air, seawater, most rocks. Examples of compound, water, carbon dioxide, magnesium oxide, sodium chloride. And you could shorten water, H2O, CO2, things like that, okay? So we're going to look at some photos here. And we're going to see if we can identify them. Remember, an element is one kind of atom, like H or Be. A compound is two or more together. A mixture is two or more things, but they're not stuck together chemically. We can't write it out like H2O, CO2, NaCl. It's just mixed together, and we can take it apart. A mixture could have elements or compounds in it, by which we mean the air has some pure nitrogen in it. That's just the letter N on the periodic table, but it also has some CO2, carbon dioxide. That's a compound. See what I mean? Okay, there's a lot of these we're going to rapid fire. A rock. In fact, I changed my mind. I was going to put these in the podcast. We're going to do these as a class. So we'll come back to this. So we're going to do these as a class. So for now, I'll just do a couple so that you can get the hang. So rocks, like we said, are going to be a mixture because I can actually break this down with some kind of physical force usually and get the different pieces apart. They might have different densities so they can float. So that's a mixture because we're able to break it down without doing a chemical reaction. Okay? Copper. I'll give you a hint. It's on the periodic table as Cu, which means it's an element. Okay? And I'll do jelly beans. Okay? Jelly beans. What do you think? Jelly beans are a mixture. There is compounds in jelly beans. There's probably table sugar, which is a compound in a jelly bean, but there's also other things like the color and everything else that makes it crunchy or chewy on the inside and crunchy on the outside. It's a mixture, okay? And lastly, table sugar, also known as sucrose. I'll give you a hint. Table sugar is not on the periodic table of elements. It is instead a compound made of three elements, C, H, and O, carbon, hydrogen, and oxygen, like most molecules that are making up living things, actually. And like we said before, this compound always has these in the same amounts. It's always C12, H22, O11. It's never different from that. If it differs from that, it is no longer table sugar. It's something different. And again, if you want to know, the fancy name for this is sucrose. Okay, I'm going to save the rest of these examples to do as a class in real time instead of on the podcast. So that's all. Make sure that every single blank got filled and that you did your shortened version, of this. Like I said, you can write it shorter. Composition, variable. But I want you to have the basics of this, okay? I will check for this, so don't play with me. Thank you. Put this paper in your binder. Okay, thanks for listening to my podcast. Bye.